Today I'll be proving or not exactly proving, but can you call it economics proof? I don't know. Or let's just say I'm going to use the word proof lightly, but I'm going to be proving the formulas John Leonard Keynes used for multipliers, like from MPS and MPC, marginal propensity to spend, etc. Without further ado, let's begin. So let's just assume, or we have to assume, that MPS plus MPC equals 1. All right? Okay, now let's consider the scenario where the government gives out money. Okay, so the government gives out some amount of money. Let's call it, what's a good variable? D for dollar, all right? The government gives out some, maybe it's 8 billion, maybe it's 2 billion, so some variable D for dollar, okay? Now, we want to see by how much it increases the GDP. So it would be something like, first time it's spent, it's D. So D, the GDP goes up by D, and then we multiply it by MPC, because the people who are using this dollar are gonna save some of it. So they only spend a fraction of that D. So the GDP, or the change in GDP, would equal the amount of money the government put in, and then D plus MPC. And then now there's D plus MPC money lying around, and it's gonna get spent again. But this time, remember, the people who are spending this money are also going to take a fraction of that money. And specifically, it's going to take a fraction of MPC multiplied by this. And then you can see that this just becomes this. All right, cubed. And then dot, dot, dot. All right. And then the final term. Okay, this approaches infinity. So it'd be like approaches the MPC to infinity. And MPC to infinity, or a fraction, let's say 0.9 to infinity, is just 0. Because 0.9 times 0.9 is 0.81. 0.9 times 0.81 is 0.729. And you can see that this, as this exponent approaches infinity, the entire term would approach 0. So we have this. Okay. Now, I want you to consider, let's just call this n. All right, let's call this n, and limit as n approaches infinity. Okay. Now, I want to multiply the change in GDP by MPC. So MPC times the change in GDP would equal D times MPC plus D times MPC squared. Remember, if I multiply MPC on the left side, I need to multiply MPC on all the terms of the right side. And then dot, 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 plus D times, and this is the final term, MPC n plus 1. Exponent rules. When I multiply MPC times MPC to the power of n, I just add 1, n plus 1, okay? So I multiply MPC on the left side and on the right side, and then I get this. Now, I want to subtract this from this. So I want to do this. MPC change in GDP minus change in GDP. And you can see that this is a telescoping series. So this will cancel out with that. That will cancel out with that. In the end, we just get this. D MPC to the n plus 1 minus D. Because look, when we subtract this from this term will cancel out with that term. This term will cancel out with that term, and so forth. This term will cancel out with something in here. And the only terms that remain would be this, which we subtract from here, from this one. So it would be negative. And this term won't get canceled out because the highest term here would be here, but it get canceled out with someone in here. So this will be the highest term, and this and this remain untouched, okay? Now we have this, all right? Now I want to factor out MPC. So MPC, wait, no, sorry about that. I want to factor out change in GDP. Because remember, we're trying to find a change in GDP here. So we just get MPC minus 1. So I factor out change in GDP, which equals, let me just factor out D too. MPC n plus 1 minus 1, okay? And I want to divide this by this. So it would be change in GDP. Yeah, I want to isolate change in GDP. So we get D MPC n plus 1 minus 1 over MPC minus 1, okay? And remember, we have a limit as n approaches infinity because the money doesn't stop getting, thrown around. So it would get thrown around n times, and this n is approaching infinity. So the money will get thrown around an infinite amount of times. So as n approaches infinity, we already said that any number less than 1 and greater than -1 would approach 0 if it has an exponent of infinity. So we know this. And since MPC we know is less than 1 and greater than 0, or it could be equal, but let's assume it's less than 1, right? Since MPC is less than 1, greater than 0, that means MPC to the power of infinity just equals 0. So you can see here that MPC, and as n approaches infinity, this top part just becomes infinity. So we get that change in GDP, sorry about that, equals D 0. This just becomes 0 because n approaches infinity. So this will have an exponent of infinity, and then minus 1 over MPC minus 1 equals negative D over MPC minus 1. And then finally equal D 1 minus MPC. So I multiplied negative 1 to top and bottom. And look, we had this, right? That means 1 equals, no, sorry about that. 1 minus MPC equals MPS, all right? So if we bring 1 minus MPC here, we get MPS. That means this bottom here is just equal DMPS. So that's the total change in GDP, all right? And so the multiplier would just be 1 over MPS. Okay, thank you.